Hello, Algebra 2 people. Here we are. We're in chapter 3, section 3.2. We recently solved systems of equations by graphing, which is kind of interesting. But graphing is not the most efficient way of doing it. Also, it's hard to tell when your answers are fractions, exactly what those fractions are when you solve by graphing. So we're going to solve systems algebraically today. And substitution and elimination are the two methods. And some people will call elimination linear combinations. So if you ever hear that, they're actually just referring to the elimination method. And I'm going to go ahead and do a few examples of each. Sometimes substitution is preferred, sometimes elimination is preferred. I'll kind of give you ideas of when to use which. Either one can be used at any given time. It's just usually there's a preference as far as ease of solving. So let's start out by solve using substitution. And our example here is 7x plus 2y equals 1. Oh, and I should mention, the book will always stack these systems of equations. They'll stack one equation on top of the other. Whenever I work them out, I always put them side by side. It gives me plenty of room to work them out, which I've found really helps people to remember what to do next. So now for substitution, what you're going to do is you're going to isolate a variable. Isolate's just a fancy way of saying get by itself. You're going to get one of these variables by itself. Then from there, you're going to substitute what it's equal to into the other equation. Now the reason we're going to do that is because we've got x's and y's. But when we substitute into the other equation, you're going to have just x's or just y's, and that's going to allow you to solve for the x or the y. Now, scanning these two problems, I'm going to look for the variable that looks like it would be the easiest to isolate. And I'm zeroing in right there at this y. If I want to get that y by itself, I am simply going to subtract this 3x over. Keeping my equation balanced, I subtract 3x on both sides, and I quickly get y is equal to negative 3x plus 3. Now I circle what y is equal to, and I substitute what y is equal to into the other equation for y. Y is equal to negative 3x plus 3. So over here where y is at, I'm going to put negative 3x plus 3. So I rewrite my equation, substitute negative 3x plus 3 in, and now instead of having an x and a y, I just have x's. And I'm going to be able to solve this. Now to solve this, I need to get these x's together, but right now it's locked up with that parentheses. So I'm going to unlock it by distributing. Now it's unlocked. I've got like terms right here, so I just simplify them. 7x minus 6x is 1x or just x. So I'm left with x plus 6 equals 1, and then subtract that 6 over, and I get a negative 5. So I'm halfway done here. I found my x value. Now I need to find my y value. And because I wrote these side by side to start out, I've got room to work right here. I'm going to take that negative 5 and I'm going to put it in for x into my other equation. I'm going to substitute again. So I'm going to get y equals negative 3 times negative 5 plus 3. Order of operations says to multiply that first. Oh, positive 15. We get y is equal to 18. Now, if you'll recall, when we solved these by graphing, we would get a coordinate as an answer. Well, that's still true here. This is a linear equation. There's some graph for that line. This is a linear equation. There's some graph for that. They cross at a coordinate. So we're going to rewrite these as a coordinate. We're going to say that our answer is -5, 18. Now here's the thing. I strongly encourage you to check your answers. Okay, check your answers. For one, it helps you remembering how to simplify, PEMDAS and all that. But for another, it can help you to get solid scores on tests and quizzes. So to check this, I'm going to put -5 in for x, 18 in for y up here. And you can punch that in your calculator, or you can do it by hand. But I'm going to get 7 times -5 is -35, plus 2 times 18 is 36. And when I add those together, looky there, I get a 1. So it checks out on that side. But it turns out it could work for one and not work for the other. So I need to check the other side as well. When I put the -5 in, I'll get -15 plus 18. And does that equal 3? It sure does. So I checked it, and I am just gosh darn certain that my answer is -5, 18. Let's move on. Same instructions, solve using substitution, and we start out with y is equal to 2 plus 5x. And we've got 3x minus 2y equals 3. So the first step is to isolate one of the variables. But we're in luck here because guess what? One of our variables is already isolated. Y is by itself. So I get my first step is done for me. I've already got y by itself, so I'll substitute 2 plus 5x in for y. And then these x's need to join up, but this one's locked. We're going to unlock it by distributing. Make sure to distribute that -2. So we're going to get 3x minus 4 minus 10x. Now the like terms can simplify. So I get a 3x minus a 10x is -7x. Minus 4 equals 3. Two-step equation. I'm going to add the 4 over to get 7. I'm going to divide by a -7 to get -1. Then from there, where do I go? Well, I've solved for x. I need to find out what y is. So I solved. I'm going to sub again. Substitute that -1 in for x. Simplify it. And my answer is -1, -3. And to be absolutely certain I got the right answer, I can check it. So put a -1 in there, I'll get -5. -5 plus 2 is -3. Y is -3. It checks out. -1 times 3 is -3. -3 times -2 is +6. -3 and a +6 makes 3. So you can write down a little bit if you'd like, but I just checked it just like that. All right, let's do one more of these. Make sure we're squared away. One more substitution problem. 3y minus x is equal to 17. 2y plus 3x is equal to -7. Scan this problem. Let's look for the easiest variable to solve for. And all my variables have coefficients in front of them, but to me this is going to be the easiest one to get by itself. I'll show you why. I need to undo this 3y, so I'm going to subtract a 3y. I'll get negative x is equal to negative 3y plus 17. They're not like terms. And then to undo this negative, I divide everything by negative, and it just changes the signs. So I've solved for x, I've isolated x, now I'm going to substitute it into the other equation. And boy, it's a similar sort of pattern on these. Before I can get these y's together, I got to distribute. Let's see, I believe that's going to be 51. Combine like terms, 11y minus 51 is equal to negative 7. I got a two-step equation again. I'm going to add the 51 over, divide by 11. Add the 51 over, I'll get 58. Divide by 11, and let's see if I got my answers. Oh wait, I'm lying here. Let me, hold on. Add 51, add 51. So they're opposite signs, so I'm actually going to get 44. Going the wrong direction there. 44 divided by 11, I just get a plain old 4. From there, take that 4, substitute it in, and I love how you got room to work when you write them side by side. B times 4 is 12, 12 minus 17 is negative 5. Negative 5, 4, and I encourage you to check your answers. Pretty quickly you can check your answers and see how you did. All right, well, let's take a look here. Let's go on. Let's go on to elimination. Oh, by the way, something that helps me to remember substitution is a little acronym here. Well, it's kind of an acronym, but for substitution, I think of solve, meaning I solve for one of the variables, I sub, and I'm going to sub again. Solve, sub, sub. That can kind of help me to remember substitution. But now with elimination, it's a little bit differently. So our instructions now are solve using elimination. And we'll start out with 3x is equal to negative 6y plus 12. Negative x plus 3y equals 6. Now, elimination, you approach this differently. My goal now is not to substitute, but to add or subtract these equations together so that either the x's or the y's eliminate or go away. And then all I will be left with is either x's or just y's, and I'll be able to solve for them. Now, to do this, to add two equations together, which is kind of a strange idea that you can add two equations together. To do that, you need to have everything lining up first. So I'm going to rewrite these in standard form first. So off to the side, if you want to write rewrite in standard form. This is in standard form, negative x, then the y, then the equal sign. I want to move this 6y over. That way everything matches. Once I get everything in standard form, I write 1 underneath the other. Kind of a different sort of thing here. Now, I want either the x's to go away when I add, or the y's to go away when I add. And right now, if I was to add this together, the x's would not go away, the y's would not go away. So I've got to manipulate this a little bit first. What I can do is, what I'm tempted to do is, because these x's, one's positive and one's negative, it turns out, if I were just to multiply this equation here by a 3, what that would do is that would give me a negative 3x, and then when I added the x's, would eliminate. But when I do that, I got to multiply both sides of the equation. Now this may seem like excessive writing, but I'm going to rewrite the whole system. 3x plus 6y equals 12. And then I'm going to distribute, and I'm going to get negative 3x plus 9y equals 18. Now that I've done that, my x's eliminate. When I add them up, they're gone. I add the y's up, I get 15y is equal to 30. I get y is equal to 2. After you've done elimination to eliminate one of the variables and solve for the other, then you revert back to substitution. You take that y equals 2 and you've got room to work right there. Negative x plus 3 times 2. Negative x plus 6 equals 6. Subtract that 6 over. Negative x equals 0. Divide the negative over. You get x is equal to 0. And our final answer is 0, 2. Now, just like before, you can check your answers. 0. 2 times 3 is 6. It checks out. 0 makes this 0. Negative 6 times 2 is negative 12. Negative 12 plus 12 is 0. It checks out. So this is another way to do it. To recap, I rewrote them both in standard form, and in this problem, I needed to multiply one of my equations by 3 to get the x's to drop out. If I had wanted to get the y's to drop out, I would have multiplied by a 2. And in particular, I would have multiplied by a negative 2 to make them opposites. Okay? Usually one is easier to get to eliminate than the other, and so I chose 3. But make sure to distribute to rewrite your equation accurately. Let's try another one. Negative x plus 2y is equal to negative 8. X plus 6y is equal to negative 16. Now this one is a little easier to deal with because first things first, both of these are in standard form. X, then y, then equal sign. X, then y, then equal sign. So I can go ahead and write 1 underneath the other. Now from there, I need to see if either the x or the y will eliminate if I add them up. And again, I'm in luck. These are already opposites, so they're going to go away. I'm going to be left with 8y is equal to, and I'm going to get negative 24 divided by 8. I get a negative 3. Substitute that over to the other side. Simplify that. Add the 18 over. And I get a final answer of 2, negative 3. And of course, you can check your answers as well to make sure you did it right. So sometimes elimination, this problem was tailor-made for elimination. already in standard form, already had a set of variables that would eliminate, tailor-made for standard form. This one required a little more work. All right, let's do, let's do one more. Let me check my time real quick. Yeah, one more. We're at about 20 minutes here. One more ought to do it. We are still going to solve using elimination, otherwise known as linear combinations. But now we're going to start out with a 2x is equal to 4y plus 8, and a 3y is equal to 5x minus 13. First things first, are these both written in standard form? Not at all. So I'm going to do that. I'm going to rewrite this as 2x. I'm going to subtract the 4y over. Now I'm in standard form. I'm going to subtract this 5x over, put it in front of the y. Now I'm in standard form, and I write one underneath the other. From there I say, if I were to add these up, would the x's or the y's eliminate or undo each other, go away? And the truth is that no, neither one would. This would be a negative 3x if I added it up. This would be a negative 1y. So that wouldn't happen. When that doesn't happen, then you're going to have to multiply. Now, check and see if you can multiply the smaller of the two numbers by something to get it to be the bigger. And on this one, I'd have to multiply by like 2 1/2. And that can be a little bit confusing with the fractions. I'm going to think of this more like I'm going to multiply both equations, okay? I can either multiply by the top equation by 5 and the bottom equation by 2 if I wanted to get the x's to eliminate. That's the least common multiple of 2 and 5. And then if I wanted to get the y's to go away, I'd want to make them both 12. So I'd have to multiply the bottom equation by 4 and the top equation by 3. It really doesn't matter. I guess just for kicks, I'll get rid of the y's. I'm going to get rid of the y's. So I'm going to multiply the top equation by 3 to make negative 12. Multiply the bottom equation by a 4 to make positive 12. I'm going to distribute and rewrite everything. I'll get 6x minus 12y is equal to 24. Negative 20x plus 12y equals negative 54. That is right, isn't it? Wait, hold on. 52. Careful. And now I can add these up, and the 12y's will eliminate. So I'll get a negative 14x is equal to, and let's see, what do we get over there? 24 and 52. Let's see, is that going to be 28? Negative 28. Divide by negative 14, divide by negative 14, and x is equal to 2. From there, what do? Well, I substitute. Take that 2, place it over here in for x, and then I'll be able to solve for y. Add the 10y over, I'll get negative 3. Divide by 3, and I get a negative 1. 2, negative 1. I should probably check my answers because I did a lot of work there. If I put a 2 right there, I'll get 4. If I put a -1 right here, I'll get -4 plus 8 is 4. It checks out. Put a -1 right here, I'll get -3. 2 right here, I'll get 10. 10 minus 13 is a -3. It checks out. We are in good shape. So this problem is about as intense as they get. I mean, I guess you could have like maybe decimals or fractions or something, but we had to not only rewrite it into standard form, both of them, but we ended up multiplying both equations to get a common number there. The least common multiple is 12. And so we had to multiply both equations. Sometimes you have to do that. Well, there you have it. Solving systems algebraically using substitution and elimination. Thank you so much for watching and have a great day.